Hi, my name is Ari Courtney, and we are here today with Ima and Alex, a world's famous figure skater who is about to compete in the NFSA. Let's take a look at the competition inside. The competition has just ended, and here is Ima. Ima, that was amazing. How fast were you rotating there?
I was spinning at about 0.67 rotations per second.
The competition. For all you viewers out there who would like a more thorough explanation of how Ima got the answer, she will now explain.
Oh, I was rotating at 4 revolutions every 6 seconds, and to make it easier to say, all I did was divide 4 by 6 to get 0.66 revolutions per second.
Makes sense. Well, Ima, since you're so smart, would you possibly tell us your angular velocity in radians per second?
Well, angular velocity is the number of degrees per second at which something rotates. To find angular velocity, we use the equation omega equals theta over t, where omega equals angular velocity, theta equals the angle through which the point rotates, and t equals the amount of time it takes to rotate through a particular angle. We will use stoichiometry to achieve our answer. We know that we are going at 0.667 revolutions per second and that there are 2 pi radians in a revolution. The revolutions cancel out and we multiply 2 pi with 0.667, ending up with 4.189 radians per second.
Thank you for your very detailed answer. So, I noticed that you have very long arms. Exactly how long are they?
From my chest to my fingertips, they're about 70 centimeters.
Wow, that's impressive. Do you think you know how fast your fingertips are moving?
Oh, you mean the linear velocity on my fingertips? Of course. For linear velocity, we use the equation v equals a over t, where v equals linear velocity, a equals the number of units of arc length through which the point moves, and t equals the length of time to rotate through a particular angle. We will again use stoichiometry and start off with 70 centimeters per radian. Since my angular velocity is 4.19 radians per second, the radians cancel out and we multiply 70 and 4.189 to get 293.3216 centimeters per second.
Wow, that's a lot of stoichiometry. So my 15-year-old niece is in math analysis and she doesn't know how there is zero linear velocity. Do you think you could explain how that is?
Sure, we'll use my spin as an example. When I'm spinning anywhere on my central axis, which is my body, will have zero linear velocity except for my outstretched arms. This is because for v to equal 0, the distance from my body to my fingertips must equal 0.
That makes sense. So, just wondering, what would your angular velocity be at these times? At these points, does it change?
The angular velocity stays the same because although linear velocity may be dependent on angular velocity is dependent of linear velocity. This means no matter how much linear velocity changes, the angular velocity will stay the same.
So, theoretically speaking, let's say you were to pull your arms into about 15 centimeters from your axis of rotation. How does this change your angular velocity? Will you be going faster or slower than you were at 70 centimeters from your center?
Well, my angular velocity would then increase to 10 radians per second. To solve for linear velocity, we start off with 15 centimeters per radian. We know our angular velocity is 10 radians per second, so the radians will cancel out and we will end up with 150 centimeters per second. This is slower than if our fingertips were at 70 centimeters.
This is very valuable information for teenies who are about to have a final in math analysis. This was Ari Courtney reporting from Channel D208 News.